So an example of an application of a trig function is actually the power coming out of the wall in your house. Power as alternating current actually follows the shape of a sine wave, moving up between a positive voltage and down between a negative voltage, as I've indicated, 60 complete cycles in 1 second. The equation V equals 170 plus 170 sine 210 pi t is the equation that models that power usage. So in question A, what is the period of the function? Well, we know that period equals 360 divided by b, but since we've got pi's in our equation, we'll deal with 360 in terms of radians, so it's 2 pi divided by b, which is 2 pi divided by 120 pi, which if we reduce that, cancel the pi's, 2 and 120, reduce to 1/60th of a second. We'll take care of questions B and C in the same time. In question C, if we want to turn on a heat lamp that requires 110 volts to start up, it will take some time after the switch is flipped for 110 volts to reach the lamp. Now with most devices that time is so short that we can't perceive it, but there is actually some time that goes by between the power getting to the device and enough power getting to the device for it to power up. So I've told you it's 110 volts and I want the time. So we'll go to the equation, we'll substitute in 110. And to graph this out and solve the equation, we need a 0 on one side. So we'll move the 110 over. And we can go to the calculator now. Change our window settings. Since we're in radians, we'll go with 0 and 2 pi. Go to the mode and make sure we're in radians, which we are. And we can input the function. So 170 sine of 120 pi. We have to put an x in the calculator, but it's the same thing. Close the bracket, minus 110. And we can graph this out. Now the window settings we have may not be good enough because we can't see the peaks or the troughs of this function. So good Ymin and Ymax would actually be derived from the value of A in the equation. A is 170, meaning the amplitude of the function is 170. So let's try changing the Ymin to negative 170 and the Ymax to 170 and see how that works out. Now if you're worried at this point that your Xmax has actually changed from 2 pi to 6.28, that's okay, because 2 pi is actually 6.28, 2 times 3.14. The calculator makes that change on its own. So graph that out now, and we have a much better look at this function. The trough doesn't matter to us, because we're looking for where this function crosses the x-axis. The two places that it does, we really only need the first one because the question's asking for the time required for the voltage to first reach 110 volts. So that would be that x-intercept on the left. We'll find it, go second trace, option 2. We'll move the cursor to the left of that point. Move it to the right, move it close to guess, and we get x equals 0.74. In this case it would be t equals 0.74 seconds. What that means is it actually takes almost 3/4 of a second for this lamp to get enough voltage for it to actually power up. This is why, especially with fluorescent bulbs that need a full voltage, there's sometimes a delay between when you flick the switch and when the device turns on.